We're now going to work with the Sqlite client, and this requires that you be in the same directory as the file that you intend to open. The file that we intend to open is session2db. So you may need, if you didn't look at the previous video in which we downloaded the session02 file, unzipped it in our directory, so that it was inside our downloads directory as an unzipped folder, and then use the terminal or command prompt window to cd into the proper directory, then you'll need to do that before you can continue on. I'm in my session02 files folder, which is inside my downloads directory. Whether you're on the Mac or Windows, the rest of what we're going to do here will be mostly the same, and I'll explain if there are places where it isn't the same. I'm going to begin by clearing the terminal window. I use the command clear to do that on the Mac, and on Windows I can use the command cls. Again, when we do a file listing, dir, you can see the session2db file is there, and this is absolutely necessary before you proceed. You need to see that the file is there, and you have to see its correct spelling so that you can open it properly. The reason I emphasize this is that when we use Sqlite, if we misspell the name of the file, or if we're in the incorrect directory, we're not in the same directory as the file, then Sqlite doesn't give us an error, but instead creates a new file with that name. And I'm going to demonstrate that right now. First, we begin by starting the Sqlite client, and this should work the same both on the Mac or on Windows if you're in an Anaconda prompt. Now remember, I'm in an Anaconda prompt, and I got there by searching for Anaconda and then choosing Anaconda prompt, which I chose just regular Anaconda prompt, not the PowerShell prompt. If you use just a regular command window, then the Sqlite command won't work. I'm going to say here Sqlite, Sqlite3, and it starts the Sqlite client. Again, that's also happening here. I used Sqlite3. It should work on the Mac. On the PC, it's important that you be in the Anaconda prompt to see that. Now I want to open the database file that I can see is right here, session2db. I'm going to use the open command and then the correct file name. And when I do that, the very next thing I'm going to do, and what you need to do as well, is tables. Now at this point we're going to be the same on the Mac and the PC, so I recommend that if you're on the PC, go ahead and issue these commands, and they should show the same results. You do an open, you give it the file name, and you do a .tables. Now at this point you should see that there are, I think, 9 tables. There may be something slightly different. You may see 8 or 7 tables in your version, but I believe you'll see 9. And in any case, you should see some tables, at least some tables. If you don't see anything, that means that you either misspelled the name of the file or you're in the wrong directory, and I'm going to demonstrate that. I'm going to close out of Sqlite, or I'm sorry, I'm going to quit out of Sqlite, .quit. I'm going to start Sqlite3, and I'm now going to say open session, let's just misspell session. Now it looks almost exactly the same, but when we try to open it, Sqlite has no problem with it. It doesn't give us an error. It simply creates a new file, and when I say tables, I see nothing. So if you're seeing no tables in a file that should contain tables, then that means that you haven't opened it correctly. And if you spelled it correctly, then the problem is that you're in the wrong directory, and you're going to need to use cd and either dir or ls to see what files are in your directory. You need to move into the correct directory. You can do that by going back to the previous video and going through each of the steps and making sure you're in the right place each time. I'm going to show you just how confusing this can be. After I create a brand new file by mistake, I see that it's here. And if there's any confusion between which one is correct or not, you can be in a world of confusion because you may have created a new file with a different name, or you may have created a file in a different directory that looks like the same one. You can try to see the file size to see if it's empty or not. But hopefully, if you're careful about what you've written and where you were, you should be able to back up and maybe remove the bad file. But be careful, because your file removal is permanent. In Windows, by the way, we use the del command to remove a file. So I'm going to go ahead and clear my terminal. And again, don't forget, it's CLS on Windows. And I'm going to, again, start my Sqlite client, open session2.db, do a tables to make sure that I have an existing file that I've opened and not a brand new one. And now I'm ready to rock. Now the next thing that I can do is work with my tables. And I'm going to work with the revenue table because it's a catch-all. Again, I'm not going to go back to Windows now because everything that we're doing here will be the same on Windows. I'm going to go ahead and try to figure out what's the structure of the revenue table. And I'm going to use another dot command called .schema. These dot commands are commands that we're issuing to the Sqlite client directly. One was to open a file. Another was tables to show us what tables are in the file. And then earlier I did a .quit to quit out. In the slides for this session, you should be able to find a list of commands that are available under Sqlite, so you can refer to that. Now this schema command tells us the structure of any given table, and it's issued as a create table statement. We'll use that statement ourselves in a second. But if you look at this create table statement, you can see the name of the table and then the name of each of the columns and their type. As we mentioned in the first video about relational databases, all columns have types. Each one has a different type. And these are two of the types that are available in Sqlite3, which is the text type and the float type. And that's for string data and float data. Now, before we go any further, I want to show you two other commands that you're going to want to issue in order to look at data inside the table, because that's what we'll do next. First, we're going to say shoot, I've forgotten the name of it. It's mode columns, that's what I thought, and headers on. And when we issue those two commands, we can now do a select query and see what's in our table. And they'll be listed as in column format with column heads shown at the top. If you don't have those two commands, you're going to see a different view of the data that's a little more compact but much more difficult to read. This is much easier to read. I don't know if you're noticing, if you know anything about the revenue table, but these fields are actually being cut off. The data is there. I believe it's Dothraki fashions and also the clothiers. And those take up more than 10 characters, but the standard output of these commands is going to be a 10-character output. That's not really a problem, and we shouldn't worry about it at the moment. There are ways to change the columns so that they're the correct width, but they're a little more trouble than they're worth at this point. We're just going to standardize at 10 characters per column. So when we did this, our first SQL query, select star from revenue, what that's asking for, and this is a basic SQL query, select all columns from revenue, and it's also implying that we're going to see all rows. And that's what we're seeing here, all 7 rows of the revenue table and all of the columns as well. So this is a basic command that you can do, and you could issue this for other columns as well, other tables as well, to see what's in those tables. I want to make one point about the Sqlite client though, and this is really important too because it can create confusion if you don't know about it. you may have noticed that I put a semicolon at the end of my SQL statement. If I don't do that, if I have an SQL statement without a semicolon, you're going to find that you get this continuation, this line continuation prompt that's basically saying, I'm ready for more query. Sometimes SQL queries take up more than one line. Some SQL queries can be extremely complicated and take up many lines. For that reason, the prompt allows you to create multi-line statements. And that's why we have the semicolon as a way to tell the client that we're done. Usually you'll just put the semicolon at the end when you're done and it'll give you the result. But you're going to need that semicolon at the end of each of the statements so that the SQL client knows you're done. However, look at these special commands to SQLite. These dot commands, which start with a dot, do not end in a semicolon. And in fact, if you use a dot command like schema revenue and you put a semicolon at the end, it just ignores the command completely. I'm not sure why it does that, but it does, and it's an important distinction to understand. When you're doing a dot command, it will be no semicolon, and when you do a regular SQL command, you're going to use a semicolon at the end. Now I don't know how to clear the window from here, so we're just going to keep feeding off the bottom. I'm going to flip over to my notes really quickly and make sure that we understand what's going on. And we've got some queries to look at. There is one other thing that I'd like to show you about the Sqlite client that's going to make things a little easier, is that sometimes you might, let's say, open up a table or open up a database and find that it's empty, like we said before. Maybe that's because you misspelled it, or maybe it's because you're in the wrong directory. I'm going to show you a special way to talk to your operating system directly. For instance, shell, and you use .shell for that. I'm going to use the Unix command ls to list out files in my current directory. In other words, I'm able to issue commands, what we call shell commands, commands that I might issue at the command line from the Sqlite client, and it can just be very convenient to do that. On Windows, of course, it's going to be a little bit different. You would say shell dir to see a listing, or .shell cd to see where you are currently. You understand that using the current working directory, or what we call the present working directory, and the file listing is all you really need to be able to see where you are. I could also issue, I believe, a cd command to get me to another directory as well. Like, let's say I wanted to go into challenge exercises. I should be able to do that. And now I'm in challenge exercises. This is a little, oh, it didn't work. I'm sorry, that doesn't work from here. Well, okay, that's fine. The shell command, we should just think about using it right now for the cd and dir or pwd commands. On Windows, it's dir to show what's in a directory and cd to show what directory you're currently in. On the Mac, it's pwd to see where you are and ls to see what files are in this current directory. Now, you may not need the shell special command, but it could be really useful if you're not sure where you are or you want to see what other files are available. Now let's look at a couple of SQL commands that we're going to use with Sqlite. We did a select command. Before we do, though, I'd like to show you a special little help that's really going to help us a lot when we're working with Sqlite, and that's the up arrow. If you hit up arrow from here and you keep hitting up arrow, you're going to find that you're looping or you're cycling through each of the prior commands that you issued earlier. And so you can resurrect an older command and reissue it to see where you are. I just did that with the up arrow to get backwards through my commands until I found the command that I wanted, and then I just hit enter to execute that command. I'm going to show you a couple of other SQL commands, and then we'll conclude this video. Another select command that you can do is you can select, let's say, individual columns. And you can also specify what rows you would like. This is asking for the state and company columns from the revenue table, where the state column value is equal to New York. And you can see from our prior command that there are 3 rows that contain a New York field. Now, SQL gets more detailed from there, and you can select multiple criteria for your rows and various other types of things. You can, ask for all rows where the cost is greater than, 100. And it's up to you how you'd like to shape these commands. Basic SQL is pretty intuitive, so we're not going to spend a lot of time on it. I can, in class, I'll show you a way to take an SQL tutorial, and you can learn quite a lot from that. It's not something that we need to spend a lot of time on. As long as you can select all data, select particular columns, and select particular rows based on a criteria from your tables, you're in good shape. The next thing I'd like to show you is inserting into a table. So I'm going to go ahead and insert into the revenue table. But actually, before I do that, I think I'm going to create a table. Let's do that first. I'm going to create a table, and just so I don't screw it up, I'm going to paste it in. But there's my query, and you can type it in, or, well, you can't paste it in. You'll have to type it in. Create table test, and then it's suggesting what the column names and their types should be. These are the 3 main types that we're going to work with: the text type, the integer type, and the float type. And as I mentioned, it's intended to indicate what data goes into those columns. And at times, with some databases, it may also restrict what data can go into those columns. We may not find that the restriction is here, but it's important that we be able to set the type of the intended data for that column. I'm using the create table syntax, which specifies the name of the table, the column names, and their types. And when I issue that and I do a tables command, I should be able to see the test table in there. I can then also drop the table quite easily. And when I do a tables command, see that it's no longer there. Don't forget that you can use the up arrow. You don't have to retype any commands. As long as you have it in your history, you can go back to it and simply reissue it by using the up and down arrows to get to the one you want and hitting enter. So I could go ahead and drop and create this table multiple times if I wish. I can also do a schema on the table, although it's really only just going to show me what I gave to it, showing the structure, and in fact just showing the create table syntax that was used to create it. And I'm now ready to use this table. Some folks ask why it is, or whether I need to capitalize certain words in my query and not capitalize others. Actually, that's more of a style concern for most databases. Most databases are case insensitive, but it actually depends on the database. Of course, there are many databases such as Oracle, MySQL, etc. And whether or not your database is case sensitive is dependent on that database. But I'm using uppercase letters for things that are SQL specific and lowercase letters for proper names like table names or column names. I'm doing that deliberately just to make the SQL query clearer, just makes it easier to read. So now I'm going to go ahead and insert values into the table using the insert into command. And I'm going to go ahead and do up arrow to bring that back up, and I'm just going to change some of the values here to make a second row. And I can now select star from the test table to see that those rows were inserted. So this is how we manipulate, work with, read from our tables using the Sqlite client. I'm going to do a quick review to make sure I didn't miss anything. No, that's basically it. I've shown you all the major queries that we're going to be used, these query statements, what we call SQL, structured query language. I've shown you the major statements that we use, and they are select, create table, drop table, and insert into. There are others as well, and if you're interested in learning much more about SQL, I recommend a website called W3 Schools. I actually have not used it directly for SQL, but I believe it's probably going to be pretty good. Simple chapters that show you the basic queries that you can use and actually allow you to try stuff out, to see the results. So it's pretty exciting, the little tool that they give you and how you can play with it in order to learn SQL. The name of that website is w3schools.com, and I recommend it for learning SQL. We're now going to learn how to work with Python and these queries, but this was the Sqlite client tutorial. I'll finally close by saying quit, and that quits me out of my Sqlite session.